Hello! Today we are going to show you how to solve a problem of the subject of application of particular antiderivatives. So, we are given this problem, this equation. Acceleration of an object is given by the equation 6t to the fourth power minus t cubed plus t squared divided by 2t squared. Now, we know that the antiderivative of acceleration is velocity and its integral is position. So, the question is, what's the velocity, the equation for the velocity of an object if at 1 second the object is going at a velocity of 10 meters per second? And what is the object's position if at 2 seconds its position is 12 meters? That is the question that we're going to answer with this problem.
Okay, so first problem, we're going to rewrite the equation and we're going to divide each term by the denominator, which will give us this result, and then we're going to integrate each one of these terms, which will give us this result. T cubed minus 2 squared divided by 4 plus t divided by 2 plus c. So c is a constant. We need to find it using these values that we're given here to actually find the complete equation of velocity.
We have our equation. We need to substitute the values in the correct way. So here we have that 1 second is time, so we substitute it on the t's. Now we equal the equation to the velocity, that is 10 meters per second. Now we isolate c, and it gives us that our answer is c equals minus 35 over 4.
So now we have c, we can put it in the original equation we have here, which will be our result for letter A.
Yes, that's our velocity equation.
So having the result of letter A, we can start letter B.
Well, thanks that we have the velocity equation, we can antiderivative it, which means that we will find the position equation. Now, we're going to write these to find the integral of our velocity equation. And then we are going to rewrite this equation like this, so we can solve each antiderivative step by step. And we are going to get this equation, which is the position equation. Now, if this is not complete, we have to find the constant, which my good friend here, Ever, is going to find and explain this.
Yes. Well, the first thing we have to do is replace the time with 2, because we are already told that when in 2 seconds the position would be 12 meters. So we replace time with 2, or t with 2, and it equals 12 meters. So we solve this and then we isolate the c. This passes here as a subtraction. And when we get that, we get c, which is minus 151 divided by 6. And now we have the complete position equation being t to the fourth power divided by 4 minus t cubed divided by 12 plus 10t squared divided by 4 minus 35t divided by 4 minus 151 divided by 6.
Thank you.
Now we write those answers down in the question. This was a case of double integration in which you have to have the answer for the first question to be able to solve the second one. And this is how you solve a case of a particular antiderivative.